All right, we're going to continue solving triangles, non-right triangles using law of cosines. All right, now there's a couple different variants of the law of cosines. Now you can use law of cosines if you have a side angle side, meaning you have two sides and an angle that doesn't match any of your two sides. So for example, let's say in this triangle, I'm going to call it ABC. All right, I know that side A is over here, all right, side B is here, and side C is here. All right, so let's say I have A and B, and I have angle C, right? I don't have a pair of matching sides and angles. I don't have, for example, a side C and an angle C. I don't have an angle A and a side A. I don't have an angle B and a side B that match, right? I only have two sides and an angle that doesn't match the other two. So we know we can't use law of sines, right? So in these cases, we need to use law of cosines, all right? And we also can't find any of our two missing angles because it's a non-right triangle and it only have one angle, all right? So we're kind of forced to use law of cosines in this case, right? Solving for whatever side is across our angle that we're given. Another thing that we can do is we can use law of cosines to find an angle given three sides, right? So in a side, side, side triangle. In these cases, you want to find the largest angle first. This is super important. Just because in your calculator, you might get a value that is a valid answer for cosine, but doesn't match the corresponding side, right? Now, you guys don't have to worry about the different cases that you might see, right? I know that in law of sines, I told you guys to skip the ambiguous cases with, like, for example, there might be two triangles for one problem. You don't have to worry about that here either, but just to avoid that issue altogether, you guys have to find the biggest angle first, and then from there, it's pretty simple. You don't have to worry about really anything else. All right, so let's look at this example. I want to solve the triangle, and here we're given three sides, right? So this is a side, side, side triangle. I'm going to use the version of law of cosines that has a cosine of an angle by itself, right? And in this case, like we said in the previous page, I want to find the biggest angle first. Now, if you guys remember from geometry, the biggest angle is going to be the one that's across the biggest side, right? So in this case, between A, B, and C, the biggest side is B. So I'm going to try to find angle B. So I'm going to use the version of law of cosines that has cosine of B by itself. So it's going to be cosine of B is A squared, so 8 squared, plus 14 squared, minus B squared, which is 19 squared, over 2AC, so over 2 times 8 times 14. All right, now if you're trying to use your calculator, I would simplify the top and then simplify the bottom. So I would do 8 squared plus 14 squared minus 19 squared in my calculator, which is negative 101. And then on the bottom, I would do 2 times 8 times 14, which is 224. All right, now don't worry about simplifying or anything. This is just to make the next step easier, right? Because notice that this number doesn't give us our answer, right? This gives us cosine of our answer, right? So to get just our answer, I want to do cos inverse on both sides to cancel it out. All right, so I'm going to do cosine inverse. So then B, our angle B, is going to be whatever we get when we do cosine inverse of negative 101 over 224 in your calculator. All right, which should get you, for B, you get 116, I'm going to say to the nearest hundredth, I'm just going to say 10th, 0.8, right, degrees. All right, so we already have an angle. If we have an angle, notice that now we can use law of sines, right? I can use law of sines to try to find another side. All right, so let's try that, right? Now that we have a matching pair, right? We have a side B and an angle B. I can use law of sines to go ahead and find another angle. And if you remember from the previous lesson, right, which you don't have to have memorized because we give you all the formulas. Law of sines, when you're trying to find an angle, you can do sine A over A is sine B over B, right? So let's try to find angle A. So I'm going to have sine of A over 8 equals sine of 116.8 over 19. Right, so I'm going to multiply 8 on both sides to get that 8 out of there. And then I get sine of A is 8 times sine of 116.8 over 19. And then once again, just like before, to get that angle A by itself, I want to do sine inverse on both sides. So I'm going to do sine inverse of whatever this is. And then A is going to be whatever you get when you do sine inverse of 8 times sine of 116.8 over 19 in your calculator. All right, so let's see what this gets us. All right, let's say to the nearest hundredth should be 22.08 degrees. All right, so we have so far angle A, angle B. All we have to do now is add up our angles and subtract from 180 to find C. All right, so to find angle C, I would do 180 minus 116.8 minus 22.08. All right, and then this gets us 41.12 degrees. All right, so this gets us all three of our answers that we were missing, and that solves the triangle, right? So that's an example of how you would use the law of cosines when you're given all three sides. All right, so now let's do an example where we're given two angles and a side. Two sides and an angle, right? But our angle doesn't match any of our two sides, right? Notice that in this example, angle A doesn't match our two sides that we're given. We're given a B and a C, and there's no way that we can find another angle with the information that we're given. So what we're going to do is we're going to use the version of law of cosines that relates all of this information together, right? So A, B, and C. That's going to be, right, you can check the formulas. It's going to be A squared equals B squared plus C squared minus 2BC times cosine of A. All right, so I'm going to go ahead and plug all the information that we have into this equation. So it's going to be A squared equals 9 squared plus 12 squared minus 2 times 9 times 12 times cosine of A. All right, and this is actually pretty simple to plug into your calculator. You can really just go straight across. Let's see what this gets us. All right, so it gets us A squared is 29 point, I'll use a couple decimal places just because this isn't our final answer. I'm going to say 29.2375, right? That's fine for now. Oh, sorry, this should be a 25. All right, and then so once we go to square root our answer, we should get A is, let's see, about 5.41 meters. All right, so now we have a side A, right? Keep in mind now we have a pair, right? I have an angle A and a side A now that we found our side. So what we can do is we can use law of sines to go ahead and try to find another side. An angle. So let's try to find, let's say, angle B. So I would do sine B over B, which is sine B over 9, equals sine A over A, which is sine of 25 over 5.41. All right, so I can multiply both sides by 9, cancel it out, right, and then you can do sine inverse on both sides to get your answer. Right, so I'll do sine inverse of sine B, and the signs are going to cancel, and then I can do sine inverse of this equation right here. This expression right here. And then you get B is whatever you get when you plug in sine inverse of 9 times the sine of 25 over 5.41. All right, so we get b equals 44.67. All right, to the nearest hundredth. All right, and now we have two angles. So now that we have two angles, all we have to do is subtract them from 180. All right, so I know that angle C has to be 180 minus 25 minus 44.67. All right, so we get C equals 110.33. All right, so that gets us all of our angles and our missing side. All right, so this triangle is solved. All right, so let's try another one. In this case, look at the information that we have. We have side A, side B, side C. All right, so I would use the version of law of cosines that gets us an angle given three sides. All right, so like we said in the first slide, we want to make sure that we're finding the biggest angle first, right? And in this case, the biggest angle is going to be the angle that's opposite of our biggest side. So C is going to be our biggest angle. So I would use the version of law of cosines that gets us cosine of C. So cosine of C, you can check your formulas, is going to be a squared plus b squared minus c squared over 2ab. All right, so we're going to get cosine of C is 6 squared plus 8 squared minus 12 squared, all right, over 2 times 6 times 8, all right, which is going to get you negative 44 over 96. All right, you guys can use your calculators to simplify the top and the bottom first before doing anything else, right? So I wouldn't plug all of this into the calculator in just one go, right? You could if you know how to use your calculator, but a lot of people make mistakes when plugging this in, right? So just simplify the top, simplify the bottom, and then go from there. All right, so we get cosine of C, cosine of angle C, is negative 44 over 96. All right, all we have to do from here now to get our angle C is keep in mind to get rid of cosine, we're going to do cos inverse. All right, so once you do cos inverse on both sides, C is going to be whatever you get when you do cos inverse of negative 44 over 96, and that's going to get you to the nearest hundredth, 117.28 degrees. All right, so that gets us an angle. So with that information, we can find another angle, right? Because we have now a pair, right? I have a side C and an angle C. I can use that information to try to find another angle using law of sines, right? So I would do sine, let's try sine B, right? I want to find B over 8 equals sine C over C, so sine of 117.28 over 12, and then multiply both sides by 8, cancel these out, and then you can do sine inverse on both sides to get your B by itself. All right, so clean this up a bit. It's going to be B equals sine inverse of 8 times sine of 117.28 over 12. All right, plug this into your calculator and you should get 36.34 degrees. All right, and now that we have two angles, all we have to do to find the last one is add them up and subtract from 180. All right, so I'm going to do angle A is going to equal 180 minus 117.28 minus 36.34. So then we get the measure of angle A is 26.38 degrees. All right, and that gets us all of our missing angles. All right, and then this is going to get us a side angle, side triangle. because we have an angle A that doesn't match any of our other two sides that we're given. So I would use the version of law of sines for this problem that gets us a side A, right? And I would do a side A because, right, if you look at the formulas that we give you for law of cosines, there's only one formula that relates angle A with side B and side C in one side of the equal sign, right? So that's going to be this formula right here. It's going to be a squared is b squared plus c squared minus 2bc cosine of a. All right, so then I would plug everything in. It's going to get a squared is 16 squared plus 12 squared minus 2 times 16 times 12 times cosine of 80. All right, plug all of that in your calculator. Right, it's actually not super difficult to put that in your calculator as long as you're organized. And we get 333 point, I'll use a couple decimal places, 3191, right? And then when you go to square root both sides, we get side A is 18.26 meters, all right? So now that we have a side A, that gets us part of our answer, we can now find our other angles, right? Because now I have side A and angle A, which we can use law of sines for. Right? So let's say I want to try to find angle B. Right? So to find angle B, I would use the version of law of sines that has a sine of B on top, right? So I'm going to do sine of B over 16 equals sine of 80. Right? So sine of A over 18.26. All right, so now I want to get sine of B by itself. So I'm going to do times 16 on both sides, cancel them out, and then I would do sine inverse on both sides. All right, so I'm going to clean it up a bit. So I'm going to get B is sine inverse of 16 times sine of 80 over 18.26. So then we get for angle B, 59.65. All right, so now we have two angles. I have angle B, and we were given angle A. We can easily find angle C just by subtracting from 180. All right, so for angle C, I'm going to do 180 minus 59.65 minus 80. So then we get for angle C, 40.35 degrees. All right, and that solves the triangle. All right, so to solve for the area of a triangle, if you're given all three sides, you can use Heron's area formula. Right now, Heron's area formula relates the three sides of a triangle with its semi-perimeter, right? So if you remember, a perimeter is just all the side measurements added together, right? So if this is A, this is B, this is C, the perimeter is this portion of it where you add them all together, right? And then S stands for semi-perimeter, right? So you divide it by 2. All right, not a super complicated example, formula if you have all of your side measurements. All right, so let's try one like this. I want to find the area of this triangle, and I'm given all three sides, right? But first, I need my semi-perimeter. So remember, my semi-perimeter is going to be A plus B plus C over 2. All right, so I'm going to get S equals 43 plus 53 plus 72 over 2. And this should get you 168 over 2, which is 84. So S is 84. All right, now that we have our semi-perimeter, I can use Heron's area formula. So my area is going to be the square root of my semi-perimeter times semi-perimeter minus A S minus B, S minus C. All right, so plugging in all the information that we have, my area is going to be 84, 84 minus 43, 84 minus 53, and 84 minus 72. All right, and if you're good with your calculator, you can just plug all this right into your calculator and not have to simplify anything else. But if you want to simplify a little more and make sure that you're not going to make any calculator mistakes, we would get 84 times 41 times 31 times 12. And then that should be simple enough to put in your calculator. But if you want to keep going, you can say that your area is, what is that, 1,281,168. All right, so just multiply all the numbers together. And then once you take your square root, you should get, your area is 1,131.89 square meters. All right, so not a super complicated formula to use. All right, it's probably some of the easier ones. I think maybe the easiest kinds of problems that you'll get regarding these last two lessons are going to be area problems, because we give you the formulas and they're not super complicated to use with the information that you're given. All right, so that covers this section, law of cosines.